today we're supposed to talk a little bit about career advice too, but maybe not necessary. We talked enough, and we can also talk more after this. But today I feel like is a graduation ceremony, sort of everyone will present what you're doing, and the final project was to progress. So just I think we should just start. Yeah. Okay, so Kusei, you want to talk about your dark forest implementation?
Yeah, is it visible?
Yeah, I can see your screen and looks quite pretty.
Okay, yeah. So yeah, my project was basically dark forests. I tried to implement it to as much complexity as possible, and I'll just give a brief demo. So, um, yeah, as you know, Dark Forest is this real-time strategy game based on ZK Snarks, and so you can spawn your a character on any planet, and that becomes your home planet. And then the objective is to move to different planets and then basically collect these resources. So I'll spawn at this location. So yeah, so now I basically spawned at 33,11, and at the bottom you see this thing. This I'm maintaining this transaction history, so all of these transactions will be displayed here, and then I can move to other locations. Um, so in the original game, there's this thing called mining. So what happens is you are initially spawned at a location, and all other locations around it are covered by this fog, which you have to basically uncover by mining. So that basically uses your CPU to discover new planets at these locations. So I've implemented a basic version of that. So at different locations, you can find different stuff. So there's different levels of planets based on the amount of resources present in it. And there's like also just empty space. For example, uh, some locations are just empty. So I'll try moving to some location here. So I choose the amount of resources I want to collect from this location when I'm moving. So I choose two, and then basically this will generate the move proof uh, using Snark.js, and then submit it to the contract, which will verify it and give a response. Um, so yeah, this, as you can see, this was successful. So I moved to this new location, and basically there's this counter here, uh, which basically denotes the amount of resources I've collected till now, and then I've also added a leaderboard functionality. So um, let me just do one more transaction. So basically, when once you move out of a planet, that's when your resources are collected. So after moving away, when I update the leaderboard, I should get like two. So yeah, so when the other players, there will be more entries here, but for now, this is my ID and this is the amount of resources I've collected. So yeah, that's basically it. Any questions or should I stop?
Okay, that's good. Any questions from everyone? So you are expecting to how far? So this is currently on testnet, is that right?
No, I've not deployed it yet, but
Not
I
deployed.
plan to do it tomorrow.
Okay, yeah, sounds good.
Yeah.
Sounds good. Um, and if people are actually going to play it, so at this point, is a playable game, right? It's just not that exciting. But
Yeah, it is playable, but it's not. It doesn't have all the functionality of the original Dark Forest game. That one has a much
Yeah.
more complicated interface, and there's a lot more features there.
Yeah.
So yeah,
Okay,
that
but
would
this
take a few
pretty good.
weeks to implement.
Yeah. Anyone else has any questions or suggestions? Anything? I think the UX looks pretty good, actually. The UI looks pretty good. Yeah. Okay. If so, then we move on to the next demo. Kathy, what will be the order?
Um, I think since we're on the note of kind of the less semaphore related application, so let's do all the least semaphore related application first. And I guess that would make me. So let me share my screen.
Yeah, you guys see the TAs are also doing the final project. So at this point, the distinction between TAs and students become very merged. They still help me with some admin tasks, but really everyone is just building now, apart from me.
So right. So unfortunately, I don't have a demo available yet, mainly because there was a lot of modification to my ideas very recently. So I'm still kind of building the first step, and I have to kind of write the circuits from scratch and also compile everything. So basically, my idea was kind of a stepping stone toward one of the 6 moonshots that Brian Goose, which is the creator of Dark Forest, to that he envisioned that there should be zk.SNARK can be used as a kind of on-chain data marketplace where people can trade private data. So for example, you can upload a low resolution image and prove that you have the high resolution version of it. So that's what my project is about how to kind of implement an app that first of all uses ZK to prove that the low res image is actually downsized from the high resolution one. And then to take this kind of one step further, but non-ZK related, well, 2 steps further is also to kind of mint an NFT that contains that downsized image, as well as the hash of the original image. And then the last step would be to implement kind of an in-browser camera so that we can also have a authentic timestamp and an immediate digital timestamp that is sent on chain when the NFT is mint. And then the optional part that I might not get to finish in this project is hopefully then, you know, how do we actually sell those data? How do we actually sell those photos? So that's the idea. Hold on, let me maybe zoom in a little bit. So right, so this is already on Harmony's Notion. So currently I'm at the first phase where I'm still building the circuits to kind of work on how to downsize a photo and how to hash a photo. It's kind of, so what, as I'm working on it, it's kind of understandable that why no one has worked on such a big circuit yet, because it's actually very hard to compile such a big circuit. The tile ceremony has to be big, and also there's a lot of kind of tricks that I have to do. So the circuits are already done. So I have already had implemented circuits that can basically downsize a slice of the image. So currently it will only work for 1 resolutions particularly, which is a 1024 by 1024 pixels image. So in addition to that, I have to slice it into 16 pieces just so that it will fit onto the circuit. And not having the contract of too big of a size. So so there are 3 pieces together. So basically, I will slice the image in the browser, and then I will generate the proof to downsize the sliced image into a smaller image. And then I also have a circuit that basically hash every single pixel of the size of the image. Of course, you may think that that's kind of dumb. Why do I need to hash the whole image? But that's, of course, then it's more secured for the data to be shared that way. If I just randomly select some pixels to hash, then it might not be a very secure way to prove that the person actually have the ownership of that original image. And then, of course, since I sliced the thing into 16 pieces, then I also have to have like a final circuit to hash the 16 pieces together. And I also already have the the script files to kind of read the image files into the input format that's needed, and also save the output format back to an image file so that you can preview what the low resolution looks like. But that's basically it. Right, and then of course I also have plans for the next two phases, which is the smart contract for NFT minting, and also the in-browser camera for taking the photo and then minting it. So kind of phase two would be putting everything from the smart contract and then the front end and then the back end circuits all together. So that's basically it. Let me see if I can have a little bit demo. I don't know if I have it right here. Yeah, I don't really have a demo yet, but I can just show a little bit of how the circuit would look like. Let's see. So the circuit is actually very simple, and the inputs are also very simple. So you can imagine the inputs are just the RGB, either the RGB values of the image, or for hashing, it's easier to just use the hash code for each pixels, which is the colors. So that would be it. But I'm still compiling the circuit as of now, so I don't have the output of the circuit yet. So that's the end of my presentation.
Good. So which phase do you plan to go to before the deadline? I think doing it all would seem quite ambitious, right? Yeah.
So I plan to, for the late deadline, I plan to at least do until phase one.
Okay. Yeah.
Right. So because phase 0 is not usable by a user, so at least there needs to be something that goes on the testnet and deployed. So
that sounds fair enough. I mean, if you make it up to phase 2, I can see it's going to be a total game changer. Like this is going to be, I mean, because so many NFTs online right now. I mean, that's why NFTs, despite being such a promising, such a market that grown so much, there's so much nonsense up there, right? I mean, there are a lot of NFTs that are just people who stole a picture from online somewhere, but if you can actually authenticate it's a picture that they have self-taken, that's already like a authenticated photo gallery. Whether you can finally securely transfer private data, I think that would be even the icing on top. Yeah, that would protect privacy. That would be even better. That sounds great. Anyone with questions, comments, suggestions, and anything? If not, then we can move on because we do have another handful of projects. So who will be next?
let's see. Hold on, let me stop sharing my screen first. So I think on that note, let's move to I guess Samar.
Yeah.
And then before we move on to more of the semaphore based ones.
Yes.
Share my screen here. Can you guys see it?
Yeah. Your mic is a little quiet, but if you put it close.
Oh.
Yeah. sounds good. Yeah.
Okay.
Yeah.
So this is my final project submission. It's an argument hasher for web protocol. What do I mean by that? First, I'd like to introduce what is the web protocol. It is an anonymized bridge. It works pretty much just like Tornado Cache, but I think it has a bit of better product market fit in Tornado Cache, since it has a little, what the, huh? Oh, it has better product market fit since it has more utility than just privacy. How it works is it has a relay layer that waits for the transaction to be confirmed on the source side, sends the proof to the destination side, which has a bridge contract that parses the command and executes the code. For that to work, it uses many Merkle routes at the same time, but that leads to the current problem they were having, that they were inputting anything from 1 to more than 23 parameters to the verifiers. And as we've seen on Roman's lecture, it costs about 6,000 gas for each input. So I decided to implement a circuit that hashes all public inputs before sending them to the verifier. So I've got a demo, but I'd like to show at least how it works. The demo is, it was just pretty much a testing ground for me. It allowed me to make sure that the solidity hashing thing was working exactly the same as the JavaScript, because the web code has TypeScript, and I had to make sure to make it work both sides. It both allows me to get the data and hash and then verify here. I had to do this little scope thing because on the web protocol, they had more than 15 variables on the stack, and Solidity does not allow for that. So I had to do this kind of trick to make it work. On the circuit side, it is very simple. I just got all the public inputs that the verifier was getting, and I hashed them all together. The trickiest part was actually getting the bit size correct and understanding that all the hex codes are translated to zeros on the 0x. But after that, it was pretty much easy. And the test is here. So I can do a truffle develop here and test. What's missing on the final project to make it go to test or to even mainnet is actually integrating it on web to make a pull request and make it work properly on their code on GitHub. And yeah, that's pretty much it.
Well, being so bold and going into this new kind of harder area of infrastructure building, but I always assume that it's harder, but maybe it's not that hard. It's just that the feeling of building something like that is a bit more frightening. But any questions from anyone? So you mentioned about the better market product fit. Is it because you think that interoperability is the higher use case than a local on-chain privacy?
I think that the mainstream user does not care too much about privacy. Yeah. And having better default privacy by using a bridge that allows for privacy would be more like what a retail user would actually use.
Yeah, I can see the argument there too, and especially if you really want privacy, you want to leave without trace. I think going cross chain might be a good idea anyway.
Yeah.
Okay, great. So next, can we have Zeki up?
Yeah, I can. I don't have a demo just yet because I didn't I just started making a front end.
Yeah, it's okay. Yeah, if we just like
see.
Kathy also didn't, so if you just told us.
Yeah, I'll
about the
just
project,
share
like,
my screen right now. Okay, so yeah, I decided to expand on the moonshot. One of the cases, it was zk message board, and there's two implementations right now. One of them uses a centralized server, so it's like not censorship resistant. They just did it out of convenience, and then one of them has like a max number of like a max group size of like 10. So that's not very scalable and whatever. Yeah. So yeah. So basically, the goal was to provide yeah, proof of membership while maintaining like anonymity and stuff. And so the user should be able to create a group, send a message from that group, and reveal their ownership of a sent message while not being able to deny ownership of a sent message. So yeah, those are just the goalposts. And so what I did that was sort of different than the previous two implementations was I added a Merkle tree, which makes it, yeah, that's just makes it much more scalable. And has fully on-chain storage. I initially, so it uses 4 circuits, so I had to build 4 circuits, and I initially used it with the Poseidon hash, but then I don't know, I couldn't figure out how to get the browser to compute, because for clients to be able to use to like interact with the smart contract, they have to produce the Merkle proof themselves, like in the browser basically. So yeah, I couldn't figure out how to do that with the Poseidon hash. So then I made another 4 circuits using the mimic hash, which hopefully that works. So these are my circuits. There's check root, which just ensures that, so that's when you create a group. It's when you create a group, you submit like a root and then some leaves, and it just computes that it was correctly, like the root is correct and stuff. It's just a matter of like succinctness instead of having the smart contract do all that stuff. And then sign message is when you send a message, basically. It verifies the leaf exists in a given root. So like basically, yeah, like the smart contract stores a bunch of roots that were submitted as groups. And then this send message will allow you to verify that you are part of a group. And then also that the preimage, and it outputs this message attestation, which is the hash of like a random salt, a secret, which is your secret, and then a message. And so this message attestation is used when you're trying to reveal that you are the owner of this message, just by proving basically that, yeah. And then just registered user is just verifies the preimage. It's just it just verifies that that the preimage of the public hash, which is the leaf, right, used in the trees. And that's basically it. And yeah, I'm still working on the front end, so I don't really have a demo, but yeah.
Sounds good. Any questions? Yeah, how's the timeline? Does it look like that in the next couple of weeks you can pull it off?
I think so. I mean, I'm just working with React, like, so it's just really about interacting with the yeah, it's just working with React. This is my first React project, so it's probably going to take some time, I guess, but like all the circuits and the contract like works and stuff, so
okay.
Yeah,
that's already pretty good. Yeah. Okay. So next up we have Ninja survey. Dong. Yes.
Hi, everyone.
Oh, you're presenting. Great.
Yeah, I am presenting. Okay, I'm sharing my screen. Hopefully everyone can see it.
Yep.
Can you see my screen?
Yep.
Yeah. Okay. So the whole idea of my project and also Tang's project is that we create this survey for people to participate on chain. Similar like to SurveyMonkey, but like in this case, no one can really trace back who said what and who voted what. So it's really good. if it is used in like a corporate setting where they want to, like where employees want to say that they don't like certain things about the companies and they feel like they can just say what they think. So I recorded this video, and this project, our project right now, the whole back end is on Harmony testnet. The front end is still local, but yeah, the whole back end is on testnet. So I'm just going to present it right now. Oops, that's too fast. Okay, so there you can create a survey. So you can put in multiple questions, and then you can invite a participant. And in this case, I just try to be quick, so I just put myself as a participant. And then the idea is each of this survey is an instance of Semaphore. So as you see, this is now deploying. Okay. So then only the people invited to do the survey can actually see the survey coming out. So the proof is running. So we generate the proof in the front end, and then send it up to the chain. Okay, so then if you are the survey owner, you can come in and you can see the result of your survey. So we generate an average score right now. That was really fast. Oops. Wait a minute. Yeah, so this is the average score. And then I think I tried to show that the survey address, this survey is actually on Harmony testnet. There you go, with all the transactions recorded. Okay. Okay, that's it. That's all my demo. You have any question?
I think maybe one thing I can say is maybe we can think more about the use case as well. I mean, eventually when you write it up, I think the company survey use case would be there. I think it's true, but I think there probably are use cases beyond that. I think we should think a bit more on how to target and advertise it as such. Probably there are lots of use cases. I mean, maybe not just within an organization.
Yeah, I feel like government survey, they can use this for people to vote on certain things, on some bills, some issues. Yeah.
You may be right that the government, the company case is kind of obvious, because if it's like a restaurant or something, well, then people just say whatever they want. Like being traced back is not a problem. If you know that I'm a bad customer, that's not a big deal. And if it's a government, well, presumably we have to trust it anyway. But I think an organization is exactly the kind of situation. If your boss runs a survey, and then said that the secretary would not know the answer of who voted what. Yeah, okay, that might be a little bit different. But let's think a bit more about use case. But I'm sure that once you build it, you would be able to think about it in time. Any other questions?
So each.
Okay. Does someone have a question? Sorry.
So each time you create a survey, it just spawns a new like contract, like semaphore instance?
Yeah,
They're
yeah.
using
It's
Bloomberg?
been, yeah.
Okay, I was just wondering.
All right, that's great. Then the next up would be, I think, a non-evoke. Yeah, so Tosin. Tosin? Shout out.
Hi, good evening. Hi. Can you hear me?
Go ahead, please. Yep.
Okay.
Sharing. We don't see your screen yet for some reason.
It's coming up, sorry.
Yep.
So I think I'll need to reopen my Zoom. I can't share my screen. I'll share it.
Oops, have to re-admit you. Does that work? Does that work, Tosin? I think you are muted.
Yes, sorry, I had to grant permission to share.
Yeah, no problem. Sometimes.
Okay,
Yeah.
can you see this?
Great.
Okay, so I created a portal, an anonymous voting portal that would allow us to, we can create polls and also vote anonymously. So the first thing is to register the identity. So I'm using mostly semaphore. So I did some test voting prior to this, but let me just start with a poll. So we can create polls, different type of polls, probably questions, voting, elections. So I added a poll expiring, and then you can pick your options. So each poll is a new coordinating nullifier on the semaphore contract. So each time you vote, you're going to send a signal to the contract with the nullifier. I'm using, right now I'm building the proofs, and then I'm now going to use it to send the signal, to broadcast the signal. So that I can, in order for me to, if the project is not fully decentralized, so most of the data are on the back end, but it's the voting data, that is using what you vote, and the identity is not stored on the back end. So it's basically between the front end and the contract. So if I try to, so right now I voted for this new poll with my identity. So if I try to circumvent it and try and vote again, Give me a second. It's going to reject the vote because, so if I try and vote again, it's going to fail because that nullifier is not going to be able to send it to the contract. It's not going to send the signal to the contract. Let me just quickly go through some of my code base. So I basically have 3 parts to the project. On the back end, which is where I'm putting basically just the poll information. That is the name of the poll and the details of the poll. Then I have the contract where I'm using this second 2.0 and I'm hashing it. So I'm hashing it with Poseidon. That's I'm hashing this. I'm hashing basically the signals and I'm using the Poseidon hash for the identity commitment. I'm also using the Poseidon hash for the signals, and then the front end I built on React. So basically, that is my project. That's my final project. So also, there are also some certain things I like to do forward. I would like to make it fully decentralized, hopefully. I've not really figured out how I'm going to do most of that in terms of putting everything on the blockchain. And also I had problems deploying. The contract was too big. That is on Harmony testnet. So right now, everything is still on my local host. So I'll probably have to rewrite some part of the contract to make it deployable on the testnet.
Okay, yeah. Sounds like the time frames looks doable within the next couple of weeks. Yeah.
Yes.
Okay, yeah. That's good. Any questions about this? Yeah. If not, then we have another voting app from Alex. One vote.
Yeah, hello everybody. Here's the camera so you can see me. If my connection is not great, sorry for that. I'm not at home right now. So yeah, let's start. Can you see the screen?
Yep.
Okay, so similar like Shada, I wanted to do anonymous voting application, which will actually be without collusion. And I actually wanted to stop people from creating fake accounts. So my architecture would look like this. We will have smart contracts, so we will use semaphore for actually anonymous signaling. Then I created one vote contract, which is the main contract of the app. It is actually semaphore client, and it has main information about all the voting processes, and from this contract, these voting processes are spawned. I also use meme C hash for hashing and Merkle tree. The idea was to try to use minimum anti-collusion interface to prevent people from bribing. And also, I wanted to use interop repository to authenticate users through their social networks so that they can't create multiple fake accounts and cheat that way. The last part here is the front-end app. I try to use React to implement decentralized application. And yeah, for that front end, users communicate with the blockchain and with with the app. So let's see how it works. Here's the landing page where user needs to connect the wallet. Currently, app supports MetaMask, but in the future, I'm planning to support multiple wallets, also the mobile wallets. Here is a little guideline for users who are using the app. So it says how it basically works. And yeah, here is the reference to this Semaphore UI repo. And yeah, also I put here the reference to zk University because that is how I started with zk. And yeah, so yeah, here, first of all, user needs to register his identity to be able to vote. So if we click here, then the error says that we need to connect the wallet. So let's do that. Connect our MetaMask. Okay, and here we can see that we are currently on Harmony testnet. Right now, application supports only Harmony testnet, but in the future, I'm planning to extend it to support multiple networks. Now, if we try to register, we're able to do it. And right now, identity commitment is created and stored on the blockchain. Yeah, here's the loading. And once you're registered, you're able to vote on some voting processes. So here, president election is the voting process, and it already exists. So this is the description of the process, and then user can choose to vote. Here, voting options, we need to select one and then vote for that process. Here are the votes that already exist. So for each proposal, we have the number of votes for that proposal. But we don't have information who voted for what proposal. So that's where anonymity is. We want to create new process. So let's for example, create yeah, like most useful classmates for this course. This is the description. This is test process. And we have to insert proposals separated with comma. So let's say John, Anna, Peter. We can create new process. And when it's created, we can see transaction details. Here's the hash of transactions, so you can search it on Harmony testnet. And then we're redirected to the voting processes page. Let's try to vote on this newly created process. So if we try to vote, it says we need to select an option. Let's say Peter. So right now, application is downloaded circuit from Semaphore UI repo, and as well the proving key. Then it will generate the proof, and then the voting process will happen. During the voting process, the verifier solidity contract actually verifies the proof, And if everything is successful, the user is able to vote. So let's wait a little bit here. Yeah, it's generating the proof. And as soon as the voting finishes, here we should be able to see the vote updated. So if we confirm that, it says successful vote, and we can see that Peter has 1 vote. If the same identity try to vote again, let's say vote again, then he shouldn't be able to vote because of the external nullifier. So each voting process is basically actually the voting process ID is external nullifier. So on each voting process, each voter can vote only once.
How do you select a group of people to give the vote to in the first place? So who are included in the group of people who are allowed to vote?
Yeah, actually, right now everyone is allowed to vote.
No.
But my plan was I actually didn't implement Macy and interrep. So my plan was to implement that interrep, and then depending on some criteria that I choose, some people are able to be part of certain group.
Yeah.
And then if they're part of that group, then they can vote. But that's still not implemented here.
And then I see a question from both
Mm-hmm.
Samar and also Shada Tosin. Yeah. Can you see from the chat window too? So
Yeah.
Samar has a security question about using the time to infer the vote.
So I don't understand this right now. Let me. Yeah. So yeah, that can possibly be the problem. Maybe VDFs can help with that. Yeah, I didn't think about that.
Mm-hmm.
And about the second one.
And then Tosin basically asked, like, can different projects implement and merge as one solution? The answer is yes and no. Yes. Basically, the bottom line is yes. So if you guys end up teaming up and forming one project, I mean, basically, I want you guys to have the best project, but sometimes coordination is complicated. So if you guys can help each other without merging, that's fine too. But the bottom line is yes. Yeah, if you can think of a way to do it.
Yeah, I would like to definitely. If Shada is up to that, why not? Because we're on the same project, right?
Yeah, same problem, but slightly
Yeah.
different approach. But I can see there will be mutual benefits. Yeah.
Yeah, exactly. And then just one more thing. If you're not on the right network, for example, Arbitrum, it should say that you need to switch the network, or if you don't have Harmony, you can add it here.
Mm-hmm.
So let's switch it. Yeah, that's it.
Okay. Yeah. It looks like a good demo. I mean, and it's useful too. We identified some issues. Any more questions? Well, if not, thank you. Then we will move on to the next one. I think that might be actually also relevant. I hope it doesn't become one big project. But Pran has a Alephria authentication. Yeah.
Yeah, so one thing I would like to apologize. I'm still sleepy because it's very early here, so my brain is in like delta state. So if I
Sorry
do or say something stupid, please don't mind. All right. Let me share my screen. Everyone can see my screen, right?
Yeah.
Okay, let me start my servers. Okay. One thing I would like to, so first of all, let me explain what I'm trying to do here. So I'm trying to create an authentication experience for the user, the way it will be when, which I imagine would look like when people will integrate single sign-on authentication using zero knowledge with other websites. So people like once the like any Web2 or Web3 application will integrate, they will only see the model. It's just the authentication process they will integrate, and it will be via an npm package. So goal is to release an npm package, and what I did just now, because my app is already authenticated, I deleted the auth token. um, just to give you a background of how any website will authenticate users is that users share the password and the ID, email ID with the backend server, and backend server responds with a JWT token or any other cookie which identifies the user, and for further communications with the platform, it will authenticate the user. So now what I am doing using zero knowledge proof is that, so I generate a token, I register the user identity on the smart contract, and then there's some, everyone can hear me, right?
Yeah.
Okay. So the user will register the identity on smart contract, and then it will again generate an auth token during the login process, share that auth token with the backend, and the backend will verify that auth token from the smart contract. And once the verification is done, it will share the token from the backend. So let me create. Okay. So this is just the basic information telling the user to make sure back up everything. This password thing is like currently work in progress. So what I also wanted to do is to set an additional password for the user, which can further enhance the security of their identity. Like even if the user will lose their the identity trap and the nullifier, which is basically, which makes the identity using zero knowledge proof and the identity commitment. So it adds a external layer of security on top of it. Also, using the password, one can block the identity and restrict access. So using password is like provides a lot of benefits. So this is just like a normal wallet phase setup. People can copy that. I'm gonna skip it because I'm not gonna copy it right now. And initially, once we register something, register, it's saved in the local storage. So password can also be used to authenticate the identity which is shared, stored in local storage for further interaction. And by the way, this is how the wallet works. Whenever you interact with the any wallet, like any Harmony wallet or smart contract, they don't store your key phrase like the wallet mnemonics. They usually derive a private key from the mnemonics, and then they encrypt it. They prefer to encrypt it with the password which you set. And if you lost the password, then you have to redo the setup. That's why we redo the setup. Okay, so once the registration is successful, people can log in. So again, here, if user has entered, save the password, we will like enter during registration. We would like to take that input again, so otherwise it will fail. But this is not implemented yet. So I'm gonna just go ahead and submit the. Oh wait, I didn't refresh. Okay, because this again here already shows authenticated. It shows. I can maybe redo the. One second. I'm sorry, there's some technical difficulty. Not found. So actually what happened is, so after it gets authenticated on smart contract, it's deployed on Harmony testnet, then it creates a auth token, which is again sent to the backend. So actually, I'm not sure this backend API is not working. So as you can see, it's the auth token is generated on the smart contract. It's in big int form, but we can convert into hex or anything. And then this is shared on with the actual server. So let me show. So this auth token and identity is shared by the client to the web server, and the using the auth token. So it's basically a timestamp based token with some external. Let me show my smart contract. Okay. Yeah. So it's based on, okay, so here we are doing, so it's basically a timestamp based auth token, which has like limited time to verify. So once this auth token is shared with the backend, they can supply the auth token and verify whether the user is saying what it is saying. So the identity will be returned from the smart contract, and it will match the identity which is shared by the user. And if it matches, then the user is what he's saying or pretending to be. So this is, and if this is successful, then we supply the JWT token, which normally works on the Web2 platform to authenticate. Let me just try once again to show. So since we already registered, we don't need to. And okay, this is running. I'm not sure, but my backend API is giving some error. But it usually, but I don't want to waste everyone's time. But I explain how it works. Maybe till the time class is on, I can bring that up and show it again. But this is how it usually works. I mean, that's anyways not part of my project. I did that as a test to show the demo. But usually people will consume this npm package, which I'll be extracting out of this web page, which will include a model for generating the identity and registering the user and then doing the authentication, and with some other things such as if identity is already created, I would just like you restore your wallet, we will provide a way to restore the identity, and couple of other things like blocking your identity, restricting access, like even if you share the auth token, you can block your auth token. So things like these, I've already thought like how can it be done.
Yep. So how would you deal with other competitors? So I think we talked a little bit about the NUID project. How would you distinguish yourself from that?
Yeah, actually, I didn't dug into deep detail about those, but the way I see I can differentiate is since it's based on zero knowledge proof, and also the way the KYC and all those things work. So for example, I can extend my use case to bring a variable of KYC and like actually connect it to more other use cases. For example, imagine that you submit your documents to a bank, you do your KYC, and they approved your KYC. So in this case, what they can do is they can like stamp your identity on the smart contract. And now when you go for any other service or maybe any other bank for doing the KYC or any other like maybe DEXs that will require KYC, what they can do is they can just verify your zero knowledge proof, and they can get to know that, okay, you are already KYC done. And even exchanges can use that because these days it's all mandatory to get the KYC done. So in that way, user will not have to even share any details with the third party to do the, and this is one way.
Space is wide, so the space is wide, so some competition is actually a good thing. It does look like that the use case can be very plenty. You can get a lot of users actually if you market it right.
Yeah.
Okay, any questions? If not, then we have last but not least our very own Hunter. We're going to talk about what SciStar. I think this is the project, right? Yeah.
Well, unfortunately, too, I do not have a demo ready, so I'm just going to be presenting some of the thinking I have so far. Let me just share my screen. And so the main thrust of this idea is how you can use authentication as a way to, I think, tackle one of the bigger problems that tech companies face, which is misinformation. And so one reason why I think the misinformation problem is so bad is because machine learning methods are not great at being able to really distinguish what is, for instance, scientific misinformation from something that is actual science, because it generally looks the same, and the features that machine learning algorithms have to go off of to classify something as accurate or not is pretty indistinguishable. In this review that I cite right here, they show that pretty much the bulk of misinformation about COVID uses statistics, uses data visualizations, actually reference doctors. And the biggest misinformation spreader was this guy's account, and he is a doctor himself. So it's really hard to know what is accurate or not using machine learning approaches. But we can maybe rethink the problem, specifically with InterRep and how they pretty much lay the foundation to show how you can make computational measures essentially of people's reputation on certain platforms. Currently, they have it as very broad strokes, but you can think about controlling for how much, say, bot-like behavior is maybe in someone's social network. So this platform can, I think, really be expanded quite nicely to kind of target maybe more to target real problems. And so you can see here, for instance, how you can define someone's reputation on GitHub as a function of maybe their followers, their stars, and their plan. But how would we maybe want to do this when it comes to verifying scientific opinions? There's this platform that academics know very well called ORCID, which links specific academics to the academic work that they produce. Many of the top journals now require you to include your ORCID ID so you can start mapping specific research to people's, say, their digital IDs. And I think leveraging this platform in a very similar way to how Interrupt is using it for Twitter and GitHub and Reddit will be one way to verify if someone who is maybe saying something actually has the credentials or the backing to say it. And we do see how in these Web2 profiles are starting to incorporate some Web3 components, such as on Twitter, you can have a NFT profile picture. And so what I'm thinking about, and maybe as a potential for something like this, is say like you have the blue check verification, but you could definitely have it scaled up to say maybe a science verification. So if a researcher is able to authenticate that they have a ORCID ID, that's the most simple proof that you could submit. So this is kind of the beta version that I'm working on now. But you'll be able to scale that up potentially by showing that people are at a specific research institution, or that people even publish articles on a specific topic. And so you can give people maybe a badge if they're on, say, Twitter and they're talking about vaccine misinformation, or excuse me, vaccine information. You could try to verify that they've actually published on those things. And of course, you can do it anonymously. And the current competitive landscape, I mean, you have all the Web2 approaches, which are largely relying on crowdsourcing. So you just show people a lot of information, then you have them rate it, or machine learning protocols. Within Web3, there's a few projects, which is, one is this TruePic project, which I don't know if it's really going still, but this is mainly tailored for things like deepfakes, where you can try to verify that people haven't manipulated an image, or you can try to incentivize people's kind of incentivize truth by giving people compensation for it. I think both of these don't really appreciate the complexity of social networks and how you generally have people who are kind of influencers in these networks, and they're not incentivized to say truthful things. They're incentivized to say what they want for their own personal gain. And so maybe an approach like this will be one way to kind of rethink this misinformation approach. And I'm in the final project, I'm trying to just do the very basic thing of verifying that someone does have an authenticated ORCID ID using the ORCID API. And hopefully one day it can be scalable to something bigger, like the points I highlighted here. Yeah, I was very quick and short, and sorry I don't have a demo, but that's really what I'm thinking about.
Yeah, it's really okay. I mean, we didn't, I mean, I understood that not everyone would have a demo in such a short time. So that's why the rest of the month would also be your so-called late submission deadline, because I expected very few people will be able to do it in such a short time, but still it's good to give you a bit of a push. I think it's great. I can actually, some of you asked about TA positions that you apply for in the next run. So we will start the course again by the last day of February, or at least during that week. And so some of you expressed interest, and basically I would hire all of you probably if you finish your project. So that would be contingent on that. And something that is, because by the time you should really finish by then, at least have something on testnet. But the other thing I can also announce now is actually, I think you guys are all going to ETH Denver if you like to. So based on the presentation today, I think everyone is doing well. So if you still are up for making the travel to ETH Denver, come and meet me. I'll be giving a talk on the 18th. So if you make it there, come say hello and we'll make over dinner or something. But I will write this down in the Discord channel, so it's not just spoken. And so we'll give you scholarships. We'll cover your flights, and hope, I mean, depends on what, we'll cover your flight and your travel up to a certain budget. So hopefully I'll see you all there. Otherwise, it's been a great class. I mean, it's been really, Hunter and I talk about how crazy it is that we managed to pull it off, starting in such a very short time, announcing right before Christmas, and and I think we've made very far. I think especially for next version of this course, and some of you will also be participating. We'll see how we scale this up together, and that will be very exciting. So thank you, everyone. Actually, round of applause for everyone. So thank you. Then let's chat on Discord.